We now discuss the solution of a problem from the section Coordinate Geometry, and the problem is on the area of a triangle involving trigonometric ratios. This question has appeared in the Joint Entrance Examination Main held on 24th June 2022 in the first session. The problem is, let capital A with coordinates 3 by square root of A, comma, square root of A, where A is greater than 0 be a fixed point in the xy plane. The image of capital A in y-axis be capital B, and the image of capital B in x-axis be capital C. If capital D with coordinates 3 cos theta, comma, A sin theta is a point in the fourth quadrant such that the maximum area of the triangle ACD is 12 square units, then A is equal to. We are given a fixed point in the xy plane, capital A with coordinates 3 by under the square root of A, comma, square root of A, where A greater than 0. The image of capital A in y-axis is given to be capital B, and the image of capital B in the x-axis is given to be C, and another point D with coordinates 3 cos theta, comma, A sin theta, that is there in the fourth quadrant, such that the maximum area of the triangle ACD is 12 square units, then we have to find the value of A. We now discuss the solution of the problem in detail. We have capital A with coordinates 3 by under the square root of A, comma, square root of A, where A greater than 0 is a fixed point in the xy plane. Because A greater than 0, it is in the first quadrant, x-axis, y-axis, and in the first quadrant, capital A is there, and it is a fixed point. The image of A in y-axis is capital B. So, what happens if you take the image of A in the y-axis, then the abscissa changes its sign, minus 3 by root A. So, B is the image of A in the y-axis. And the image of B in the x-axis is C. And when you take the image of B in x-axis, the abscissa remains the same, ordinate changes its sign. So that will be, this is C, that will be in the third quadrant. So A is in the first quadrant, and its image in y-axis is in B, is in the second quadrant. Its image in the x-axis is C, the C will be in third quadrant, and we are given capital D with coordinates 3 cos theta, comma, A sin theta is a point in the fourth quadrant. Agreed. Thus we have ACD is a triangle, and the area of ACD, the maximum area of the triangle ACD is given to be 12 square units, and we have to find the value of A. And the area formula is here. The area of triangle ABC is 1 by 2 x1 y1 1, that is the determinant with first row, x1 y1 1, x2 y2 1, x3 y3 1, where x1 y1, x2 y2, x3 y3 are the coordinates of the vertices of that triangle. So using this, we have A the coordinates are known, C, the coordinates are known, D, the coordinates are known. Therefore, the area of the triangle ACD is equal to 1 by 2 into the determinant, whose first row is 3 by root A, comma root A 1, okay. That of C, minus 3 by root A minus root A 1. That of D, 3 cos theta A sin theta 1. So that is the area given as a determinant. Now what we do is, to the first row, to the entries of the first row, add the corresponding entries of the second row. That is, in the place of R1, you write R1 plus R2. Then you will get, this will be 0, this will be 0, and this will be 1 plus 1, 2. So that will be equal to 1 by 2. The first row, 0, 0, 2. Second row, third row remains the same. Now 1 by 2 into, expanding this determinant by the first row, will get 2 into minus 3 root A into A sin theta. That is minus 3 root A sin theta, minus into minus plus 3 root A cos theta. And because we are taking the area, we have to take the modulus, because it should be a positive quantity. So in the modulus we have written this one. We continue in the next slide. So now 2 cancels, and that will be equal to 3 root A is common, 3 root A into modulus of cos theta minus sin theta. And how do I get the maximum area of triangle ACD? That you will get it as 3 root A into mod of maximum value of cos theta minus sin theta. The maximum value of cos theta minus sin theta is square root of 2. That is 3 root A into root 2. Why? Because the maximum value of A sin theta plus B cos theta is under the square root of A square plus B square. So here A is minus 1, B is plus 1. Under the square root of A square plus B square is root 2. Now it is given that the maximum area of the triangle ACD is 12 square units, and we have to find the value of A. So 3 root A root 2 is equal to 12. Cancelling throughout by 3, we will get root of 2A is equal to 4. Squaring on both sides, we will get 2A is equal to 16. And this will imply A is equal to 8. And that's our answer. So that is the discussion of the solution of a problem from coordinate geometry, and the problem is on the area of a triangle involving sin theta cos theta, and it is a simple and straightforward question. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.